This is Unit 8, Solutions and Solubility, Lesson 3, the types of solutions and solubility curves. How does the amount of dissolved solute impact the solution? The objectives of this lesson: I can determine if a solution is unsaturated, saturated, or supersaturated based upon the appearance of the solution. And I can determine if a solution is unsaturated, saturated, or supersaturated using Table G. So quick do now. So there are three different types of solutions. An unsaturated solution is where more solute can dissolve inside my solvent. A saturated solution is where no more solute dissolves, so I'm right at that saturation point. And supersaturated solutions are unstable and crystals can form. So this would be oversaturated. This is a unique type of solution. Table G tells us about our solubility curve. So get your reference table out now and look at this with me. On Table G, you'll see a whole bunch of lines, kind of like a kindergarten drew a bunch of stuff. And the way we read this is if I have a temperature and an amount underneath this curve for that solute, then I'm unsaturated. If at a certain temperature I am on that line, so I have just that right amount of solute per 100 grams of water, then I'm saturated. And then if I have more, or I'm above that line, so more than that line, then I'm supersaturated. So I'll do some examples of that in a moment. On Table G, there are three gases. These three lines show a decreasing solubility with increasing temperature, because if you recall from our last lesson, solubility decreases as temperature increases for gases. So these three lines represent the gases NH3, HCl, and SO2. Remember, the solubility of all gases decreases with that increasing temperature. Why? Recall why. So to determine the type of solution on Table G, you are going to first locate the temperature in the question. So the question will give you a temperature. On that temperature, you're going to go up the temperature line, and you're going to stop when you reach the grams of solute in the question. If you stop on the curve, you have a saturated solution. If you stop under the curve, you have an unsaturated solution. And if you stop above the curve, you have a supersaturated solution. So example 1, the type of solution. If you dissolve 50 grams of sodium nitrate at 30 degrees Celsius, what type of solution did you make? So step 1, you're going to find your temperature. So 30 degrees is our Celsius is our temperature. So on Table G, you're going to find 30 degrees Celsius. Then you're going to go up that line until you find 50 grams. So this is in 50 grams of solute per 100 grams of water. So I'm going to go up until I get to 50. So that's right about that spot. Then I'm going to look for NaNO3. Where am I in relation to that line? So on that line, it looks like I'm a little bit above. The line for NaNO3. Make sure you read the lines carefully. NaNO3 is this one right here, and that line is way up here. So if I stopped under the line, I have an unsaturated solution. I'll spell it all out. Unsaturated. Okay. So example 2, let's try another one. How much will dissolve? So according to Table G, what is the maximum amount of KNO3 or potassium nitrate that can be dissolved in 100 grams of H2O at 60 degrees Celsius? So looking back at our Table G, I'm going to use the same one from before. Let me erase the little marks I made on here. I am at 60 degrees Celsius, so I'm going to find 60 degrees Celsius is right here. I want to know what the maximum amount of KNO3 that can be dissolved in 100 grams of H2O will be. So the maximum amount that I can dissolve will make me saturated. That's what that phrase means. So if I'm saturated at 60 degrees, I'm going to go up that line to KNO3. Let's find KNO3 is right here. And so that's this line. So going all the way up to the line, right on that line is going to be about 105 grams. So I can add 105 grams of KNO3 to 100 grams of water, and that will make me saturated. That's the maximum amount of KNO3 that I can add to form a saturated solution. Example 3, adding solute to unsaturated solutions. So a solution of KCl contains 20 grams of KCl in 100 grams of H2O at 30 degrees Celsius. How many more grams of KCl must be added to make it saturated? So I'm going to go back up to my line diagram here on table G. So you should look with yours. I'm going to erase my KNO3 question. So I'm looking at KCl at 30 degrees Celsius. So KCl at 30 degrees Celsius. Here's 30 degrees Celsius. KCl is, where are you? This line. So make sure you're very careful about which line you're looking at. It's right there. So in order to be saturated, I have to be at about 35 grams. So 35 grams will make me saturated. I already have 20 grams inside my solution. So I'm going to subtract that 20 grams. So that will get me 15 grams. I have to add 15 grams of KCl more in order to get a saturated solution. Example 4, cooling a solution. How much will precipitate out? A saturated solution of KNO3 is cooled from 70 degrees to 25 degrees. How much of the KNO3 will precipitate or become solid? So if I go back up to my table G, I'm going to erase the marks from my last question. And I am looking for, I already forgot what it was, KNO3 from 70 degrees. So KNO3 is way up here. I'm at 70 degrees. So at 70 degrees on KNO3, I have about, I'd say 132 grams. So at 70 degrees, I have 132 grams. If I cool that solution, I can't hold as much because as I decrease my temperature, my solubility goes down. So I'm going to cool it all the way down to 25 degrees Celsius. So that's about here. So at about 25 degrees Celsius, I now can hold about 40 grams. So how much will come out? So if I started with 132 and now I can only hold 40, so 132 minus 40. So let's pull up my calculator because I can't do basic math in my head, and you don't have to either because you have a calculator you can use. 132 minus 40 grams is going to equal 92. So I will have 92 grams settle out. All right. And example 5, if the problem does not use 100 grams of solvent or water, then I'm going to do something a little bit different. According to the reference table G, the amount of NH3 that can be dissolved in 200 grams of water at 30 degrees Celsius is, so 45 grams of water, 45 grams of NH3. So if you look at table G, you'll see 45 grams of NH3 will make it saturated in 100 grams, but I have 200 grams of water. So if I double the solvent, I can dissolve twice as much solute. So if I can hold 45 grams in 100 grams of water, then I can have 90 grams in 200 grams of water. So let me see how many practice you've got. 2 practice. All right, I'm going to have you do these 2 practice on your own because I did 5 examples. Do this practice and do this practice, and I will go over them in class. So these 2 will not be graded for your video, but to stop and think, you should do these practice and check your understanding. Okay, so now you can determine if a solution is unsaturated, saturated, or supersaturated based upon the appearance of the solution. And you can determine if a solution is unsaturated, saturated, or supersaturated using table G.